Over the past few years, the world has been told the AI race is a battle between artificial intelligence companies, a battle between OpenAI and Google, between Microsoft and Amazon, between American technology giants competing to build the smartest models humanity has ever created. But there is another company quietly sitting at the center of this entire race. In less than a decade, NVIDIA transformed itself from a company known mainly for gaming graphics cards into the most important infrastructure provider of the artificial intelligence revolution. Its chips power the training of the world's largest AI models. Its software ecosystem controls how those chips are used, and its technology has become the foundation upon which the AI industry is being built. The question is no longer whether NVIDIA is part of the AI revolution. The bigger question is, did NVIDIA become the company that owns the road everyone else has to travel? When ChatGPT was released to the public in late 2022, millions of people experienced artificial intelligence for the first time. The world focused on the models. People debated which company had the smartest AI system. But behind every conversation with an AI model, there was something far less visible. A massive industrial machine consuming enormous amounts of computing power. Training a modern AI model is fundamentally different from running traditional software. Traditional software follows instructions written by humans. Artificial intelligence learns patterns by processing enormous amounts of data through billions or even trillions of parameters. The larger the model becomes, the more computation it requires. And this created a new economic reality. The future of AI would be limited not only by algorithms but by access to computation. For decades, technology companies competed for data. Then they competed for users. But in the AI era, the most valuable resource became something else: compute. The ability to perform massive amounts of mathematical operations quickly and efficiently. This is why the world's largest technology companies suddenly began spending money at a scale rarely seen before. Microsoft, Amazon, Google, and Meta started building enormous AI infrastructure projects. Their capital expenditure budgets reached hundreds of billions of dollars. This was not a normal technology upgrade. It was an arms race. By the middle of this decade, analysts estimated that the world's largest cloud providers could spend between $660 and $690 billion on infrastructure investment. A significant portion of that money was flowing directly into artificial intelligence systems, data centers, networking equipment, power systems, and most importantly, AI accelerators. And that is where NVIDIA entered the center of the battlefield. To understand NVIDIA's dominance today, we have to go back more than 20 years. In the beginning, NVIDIA was not an AI company. It was a graphics company. Founded in 1993 by Jensen Huang, Chris Malachowski, and Curtis Preem. NVIDIA originally focused on one question: how can computers generate more realistic graphics? The company's breakthrough came from developing the GPU, or graphics processing unit. Unlike traditional CPUs, which were designed to handle a small number of complex tasks sequentially, GPUs were designed to perform thousands of smaller operations in parallel. At the time, this technology was mainly useful for video games. But Jensen Huang saw something much bigger. He believed that parallel computing would eventually become the foundation of a new generation of computing. The GPU was not just a graphics processor. It could become a general-purpose engine for solving complex problems. In 2006, NVIDIA made one of the most important decisions in its history. The company introduced CUDA, a software platform that allowed developers to use NVIDIA GPUs for general-purpose computing. Before CUDA, GPUs were mostly locked inside the world of graphics. They were powerful, but difficult to program for scientific research, engineering, or artificial intelligence. CUDA changed that. It created a bridge between NVIDIA's hardware and the developers who wanted to use it. But at the time, many people questioned the decision. NVIDIA was spending enormous resources building software infrastructure for a market that barely existed. Artificial intelligence was still a niche research field. Deep learning had not yet transformed the world. The company was essentially betting that one day millions of developers would need massive parallel computing. It was a risky bet. But Jensen Huang believed that the future of computing would not be defined by faster CPUs. It would be defined by accelerated computing. CUDA became the foundation of NVIDIA's future empire. Because NVIDIA did not just create a faster chip, it created an entire ecosystem around that chip. Over the next 2 decades, developers, researchers, and companies built millions of lines of optimized software around CUDA. This created something much more powerful than a hardware advantage. It created dependency. A research breakthrough would transform NVIDIA's risky investment into one of the most valuable technology decisions in modern history. The moment was called AlexNet. In 2012, a small research team from the University of Toronto changed the direction of computing forever. Their neural network model, AlexNet, achieved a breakthrough result in the ImageNet competition. But the most important part of the story was not only the algorithm, it was the hardware that made the algorithm possible. AlexNet was trained using NVIDIA GPUs. The researchers discovered that the massively parallel architecture of GPUs was far better suited for deep learning than traditional processors. What had originally been designed for rendering video game graphics suddenly became the engine powering artificial intelligence. Jensen Huang later described this moment as the event that ignited modern AI. Because for the first time, researchers realized that artificial intelligence would not only depend on better algorithms, it would depend on a new form of computing infrastructure. The old data center was designed around storage and general-purpose computing. The new AI data center would be designed around acceleration. Instead of machines waiting for instructions, thousands of specialized processors would work together to create intelligence. NVIDIA's transformation did not happen overnight. It required nearly 2 decades of continuous hardware innovation. Each generation of GPU architecture introduced new capabilities that pushed artificial intelligence further. Tesla era. The Tesla generation established NVIDIA's vision of using GPUs beyond graphics. These chips created the foundation for scientific computing and early machine learning workloads. At this stage, NVIDIA was still preparing for a future that had not yet arrived. Pascal era. In 2016, Pascal introduced technologies that would become essential for AI systems. High bandwidth memory allowed processors to access data faster. NVLink created a faster connection between GPUs. The idea was becoming clear. Future AI would not run on a single chip. It would run on thousands of connected processors working as one system. Volta era. Then came Volta. The Tesla V100 introduced Tensor Cores, specialized hardware designed specifically for artificial intelligence calculations. This was a major shift. NVIDIA was no longer simply adapting graphics processors for AI. It was designing chips specifically for the AI revolution. The message was simple. AI workloads require different hardware, and NVIDIA was building that hardware before the market fully understood the opportunity. Ampere era. In 2020, NVIDIA launched the A100. It became the foundation of the first generation of large-scale AI infrastructure. Cloud companies, research institutions, and technology giants began building massive AI clusters around it. The A100 became one of the most important computing products of the decade. It powered some of the world's largest AI training systems, but the real explosion was still ahead. In November 2022, ChatGPT changed everything. Millions of people discovered that artificial intelligence could communicate, create, analyze, and reason. But behind this simple interface was an enormous computational challenge. Training and operating large language models required thousands of advanced GPUs. The demand for computing power increased faster than almost anyone expected. NVIDIA's next-generation Hopper architecture arrived at exactly the right moment. The H100 became the most sought-after AI accelerator in the world. Designed specifically for transformer-based AI models, the H100 introduced the transformer engine, allowing AI systems to perform calculations more efficiently. The chip became the foundation of the generative AI boom. Suddenly, every major technology company faced the same problem. They needed more H100 GPUs, and there were not enough available. In previous technology revolutions, companies competed by building better software. In the AI revolution, companies were competing for access to computing capacity. And the most important resource was controlled by NVIDIA. The entire AI ecosystem began to revolve around a single supply chain. NVIDIA designed the architecture. TSMC manufactured the chips. Cloud companies bought them. AI companies used them. Billions of dollars invested into artificial intelligence eventually flowed through NVIDIA's ecosystem. The company was no longer simply selling processors. It was becoming the infrastructure layer of AI itself. Jensen Huang began describing a new concept. The AI factory. In the industrial age, factories transformed raw materials into physical products. In the AI age, factories transformed data and computing power into intelligence. According to Huang, the next industrial revolution would not be powered only by software. It would be powered by enormous AI factories producing a new type of commodity, artificial intelligence itself. And to build these factories, NVIDIA created its next generation of systems, Blackwell. For decades, the basic unit of computing was the processor. The computer was defined by the chip inside it. But artificial intelligence changed this idea completely. The future of computing would not be measured by individual processors. It would be measured by entire systems. Jensen Huang described this transformation with a simple idea. The rack itself has become the computer. NVIDIA's Blackwell architecture represents this new generation of computing. A system like the GB200 NVL72 is not simply a collection of individual chips. It is a tightly integrated AI supercomputer designed to operate as a single massive intelligence engine. Inside one rack are dozens of Blackwell GPUs connected through high-speed networking. Together, they create a unified computing system with enormous memory capacity and unprecedented communication speed. This represents a fundamental change in computer architecture. In traditional computing, processors mainly worked independently. In AI computing, thousands of processors must behave almost like one giant brain. The challenge is no longer only computation. The challenge is communication. Many people believe NVIDIA's dominance comes from making the fastest chips. But that is only part of the story. The deeper advantage is the entire ecosystem built around those chips. For nearly 20 years, NVIDIA has invested in a complete software and hardware stack. Developers do not simply buy a GPU. They enter an entire computing platform, CUDA. The invisible empire at the center of this ecosystem is CUDA. CUDA is the software platform that allows developers to use NVIDIA GPUs for artificial intelligence, scientific computing, and high-performance applications. The power of CUDA is not just the technology itself, it is the accumulated knowledge built on top of it. Over nearly 2 decades, millions of developers have optimized their software around CUDA. Thousands of AI tools, libraries, and frameworks have been designed specifically for NVIDIA hardware. This creates a powerful barrier. A competitor may design a faster chip, but replacing the entire software ecosystem is a much harder problem. Artificial intelligence is not only a race for faster processors, it is also a race for faster communication. When training a large AI model, thousands of GPUs must constantly exchange information. Every calculation depends on how quickly one processor can communicate with another. NVIDIA's NVLink technology creates a high-speed connection between GPUs. The latest generations provide bandwidth far beyond traditional computer connections. This difference becomes critical when training enormous AI models. A faster chip is useless if the system cannot move information quickly enough. NVIDIA also developed NCCL, a communication library optimized for large-scale AI training. It manages how thousands of GPUs cooperate as a single computing system. In other words, NVIDIA does not only build the engines, it builds the roads connecting those engines. Once the AI race began, the world's largest technology companies faced the same question. How many GPUs can we secure? Microsoft became one of NVIDIA's largest customers. In 2024, the company acquired hundreds of thousands of Hopper generation GPUs, including H100 and H200 systems, to expand its AI infrastructure. The scale of this investment demonstrated a new reality. AI leadership required industrial-scale computing capacity. Meta also accelerated its AI infrastructure investment. The company purchased hundreds of thousands of NVIDIA GPUs and announced plans to deploy millions of future generation accelerators. xAI Elon Musk's xAI built one of the world's most ambitious AI computing clusters. Its Colossus supercomputer was designed around NVIDIA Hopper GPUs. These companies were not simply buying hardware, they were buying access to the future of artificial intelligence. There is a remarkable pattern inside the AI economy. Investors fund AI companies purchase computing power, cloud providers build massive infrastructure, and much of that spending eventually flows back into NVIDIA's ecosystem. This is why NVIDIA became different from previous technology companies. It does not need every AI company to win. It benefits from almost everyone trying. NVIDIA's rise is one of the most dramatic transformations in modern technology history. A company that was once associated mainly with gaming graphics became the company supplying the foundation of the world's most important technological revolution. The numbers tell the story. In the fiscal year 2017, NVIDIA generated roughly $5 billion in revenue. Less than a decade later, driven by artificial intelligence infrastructure, annual revenue had grown by more than 40 times. The most important change was not only the size of NVIDIA's business, it was the identity of the company itself. Gaming was once NVIDIA's largest market. Today, the data center business dominates the company. NVIDIA is no longer primarily a graphics company. It has become a full-stack artificial intelligence infrastructure company. Semiconductor businesses have historically been extremely competitive. Companies fight for every percentage point of performance. Manufacturing costs are high. Prices eventually fall. But NVIDIA operates differently. Because it does not only sell silicon, it sells an entire AI computing platform. Customers are not buying only a processor. They are buying compatibility, optimization, software libraries, networking technology, and a complete ecosystem that allows AI systems to operate at massive scale. This is why NVIDIA achieved profit margins rarely seen in the semiconductor industry. The company created something closer to an infrastructure platform than a traditional chip business. Jensen Huang often explains accelerated computing with a phrase that sounds almost contradictory. The more you buy, the more you save. The reason is simple. In traditional computing, adding more servers usually means adding more cost. But in AI computing, specialized acceleration can reduce the time, energy, and infrastructure required to complete the same workload. Higher performance can actually reduce total cost. But every technological empire eventually faces a challenge. And for NVIDIA, that challenge is emerging from one of the world's largest technology markets, China. Export restrictions prevented NVIDIA from selling its most advanced AI accelerators to certain Chinese customers. The company created modified products to comply with regulations. But the restrictions accelerated something unexpected: the search for alternatives. Chinese technology companies began investing heavily in domestic AI hardware ecosystems. Huawei's Ascend platform became one of the most visible alternatives. The goal was not only to build a faster chip, it was to create an independent AI infrastructure stack. Hardware, software, developer ecosystem, everything. Then came another important development. A new generation of AI models demonstrated that software innovation could sometimes compensate for hardware limitations. By improving training methods, optimizing algorithms, and reducing computational requirements, researchers showed that intelligence could become more efficient. This created a deeper question. If better algorithms can reduce the amount of computing needed, does NVIDIA's dominance have limits? The final transformation may be even bigger than NVIDIA itself. Countries around the world are beginning to view artificial intelligence infrastructure as a strategic resource. In previous centuries, nations competed for oil. Later, they competed for semiconductor manufacturing. Now, they are competing for artificial intelligence capability. This is why Jensen Huang talks about sovereign AI. Nations want the ability to build and control their own AI infrastructure. The AI factory is becoming the new industrial foundation. Instead of producing cars, machines, or physical goods, these factories produce intelligence. In 1993, 3 engineers started a company with a simple belief. The future of computing would require a new kind of processor. They could not know exactly how the future would unfold. They did not know that GPUs would become the engine of artificial intelligence. They did not know that a software platform created in 2006 would become one of the strongest technology ecosystems in the world. But today, almost every major AI company depends on the infrastructure NVIDIA built. OpenAI needs compute, Microsoft needs compute, Meta needs compute, Google needs compute. Every company trying to build the future of artificial intelligence needs access to the same foundation. The AI race is often described as a competition between companies building smarter machines. But behind every intelligent system is a much larger industrial battle. A battle for the chips, the software, the networks, and the factories that make intelligence possible. In the age of artificial intelligence, the company that controls the foundation may shape the future. And right now, that foundation belongs to NVIDIA, NVIDIA.